afternoon again, everybody. So we're now having the last session of today. Professor Saharon Shelah will be talking about iterated forcings for inaccessible cardinals.
So, historically, there are many things to be mentioned. If I will explain it well, it will take all my time, and this is not the. So I adore history, but this is not the aim of the lecture, so I will not. So the thesis is countable support iteration of proper forcing. Length Aleph 2, assuming CH. This is a paradise. Okay, so we don't go into it, but we are on Earth, so it is not so paradise. So we have lambda is weak power of lambda. Well, maybe large, can squeeze down with some price, sometimes at least. Okay, now, of course, in paradise we can't expect to have an ideal neat theorem, particularly even for, so here is lambda is Aleph 0. Even for lambda plus CC less than lambda support, we have problems. Still, there are some theorems, and I can tell you a lot. There is exposition is 1063. This is number of in my list. So this expose and also say something. Never mind, and give history. But now, as we see in lambda CC, we have schizophrenia. In what sense? Even for Aleph 0, there are many interesting versions of the CCC, but still, the one of just CCC has a central place, and it is to a large extent ideal, so can be, say, paradise, but for larger, it splits. There are many which are incompatible and not so canonical. So here we have, in fact, more. Now, so here, with this, we have much more expectation of this. No, the generalization. So now this is now some over-industrious people try to say, oh, I will look at the web in this, but F numbers are like my, what I say, איך אומרים עלייה? What? עליית הגג ששם אתה שם. Ethic, some you say all the things which are not, not as, okay, so this is draft or etc. It is like possibly, or what is promised by co-authors which after many bad experience, even if they swear by their fathers, I say fine, but you will get a number when I get a real number when I see a TypeScript, yes? So I find it unnice to have empty numbers. Okay. So this is that. And now So the problem is this: there are many very nice possibilities, which each one has its pro and con in complicatedness, etc., and covering. So we will concentrate on one. Lambda proper, well, lambda plus not collapsed, lambda plus CC, and lambda bounding. Yes. Now, I have one request from the audience, which sound totally trivial, but in practice appear to be very hard. If you don't understand, please ask. So I heard many educators say how they educate people to ask questions and to wonder and to make dialogues. But if I looked at the end product, I don't see where this is helpful. So please, Menachem, אולי אתה תסביר.
What do you mean by lambda bounding?
Oh, okay, this is very easy. Oh, however, those of you who didn't hear me, if you ask a question, you have to pay not large but a small price. The price is to hear the answer. Because the problem is many times you say, I start to give the answer, oh yes, I remember, I now understand. So, but maybe there was somebody else shy who didn't dare to ask. And also it isn't nice to say half sentences. So you will hear all. I think it is a fair. For every function in the new universe, there is a function in the old universe so that F is below G. Okay?
Everywhere.
Well, everywhere, I forget to say then lambda complete.
Okay.
Now, there are many dear and exciting forcing which are either not just CCC and increase to lambda on the one hand, and on the other hand, there are all descendants of Prikri, which Menachem Megidor and Moti and others have done much too, but not at the moment, yes. And there are many other versions here. So, no lambda Cohen, okay? Which, in fact, if you agree to add Cohens, then many times lambda plus CC is enough. Anyhow, you have a good chance of it because it is a major property of lambda plus of less than lambda support iteration that Cohens are added for free in the limit, whether you have originally wanted or not. So countable support iteration is certainly needed when you don't want. Now, of course, you may say that you want to omit this and have but have no Cohen. This is very exciting, and this contains many beginning on this, but as I say, I have want to look at one case, because if you look at too many, you eventually doesn't get finish anything. Yes. At least in the lecture. Okay. So, but of course, to say that we are not on paradise. In paradise, we have every proper forcing. We are on Earth, so we have to, of course, for some other point of view, this case of length Aleph 2 is the infinity, but okay, for us it is a paradise. Okay. So what we do, we use creature iteration. Creature iteration or creature forcing. Okay, to describe it in short, I will say that if you have general topology, and here you have R2, R3, R4, you will be in, I forget it, there are reasonable spaces which look locally R on N. Yes. So if you have here proper forcing, and here you have Sachs, say lever forcing, etc., this is where creature forcing are. They are, compared to this, they are very general, yes, but compared to this, they are extremely specific. Okay? And as we have said, we also assume bounding, yes? Okay. Now, what is next? So there is, the question is how to iterate it, and we use, there are several ways, but again, I choose here the simplest one. And but first we have to say something on the single. So in some sense, the creature means that, well, for present it will be that we have a tree which have lambda levels. We have lambda levels, and then in each level we have a splitting to less than lambda. And as I say, lambda inaccessible. Later we will have to go higher, but we will see. So, definition, Q if it is described by T let us suppose it is T okay, and T less than lambda is union. Okay, so this is a tree. So the creatures will be on the tree. We will have okay, so and we have for everyone here is C and eta creatures, e.g. a forcing notion which is theta or maybe okay, we will make the tree uniform, we already decide, which is complete. Okay, so in fact, usually in creatures, which you can see in my work with Andrei Roslanovsky, you have, instead of completeness, you have things called bigness, which is a weak representation of, say, have an ideal. Never mind. This is what we have. E.g., really, so each P has set of possibilities which is included in theta 1 epsilon. The tree look like this is a trunk, and then we have a tree where the splitting are by a creature which tell us what is the set of possibilities. And for a bigger condition or more informative condition, we will lengthen the trunk and shrink those according to some rule. Yes, if it is a forcing, we take a bigger element, so smaller set of p's. Yes. So yes. Mean we have is possibility D is smaller. Yes, can man have?
No, and what do you assume about the utility of smallness?
I have. Oh, this will have, of course, less than lambda. Yeah. If it is a forcing. And also here, sigma C is less than lambda. Probably it is, usually it is much smaller in fact. Okay. What? C, D are creatures. Those sits on a node and tell me what you are allowed, a restriction of what you choose there. Now, generally, there are gluing, which is putting creatures together. But as I have said, this I have many more possibilities, but I will try to look at them. So now, P belong to Q, which is a creature and sigma, if and only if P is TP, okay, trunk P. This, we are trying to add a generic. The generic will be a branch of this tree. So we start by, we have to say some, and we are looking at less than lambda complete forcing. So of course we have to give a condition will give initial segment. Okay, TP is a closed subtree. This is, maybe you say Q0. This is far from the true definition, but this is the first approximation. And C is C epsilon, length of the trunk. In fact, okay. Yes, okay. Eta belong to TP, length eta is at the end. Okay, you can say the trunk is eta. Well, below the length of the trunk you have already decided, so there is no point to make promises. Yes, you already have decided. Yes. After it, of course, there is you still have, so you can make promises. In the end of the day, after you force, of course, there are no more promises. There is also a trunk, like in elections. The promises are just before the election is done. So this is when you force, you have this. After you force, you really, the only thing remain of interest is the trunk, which together give you a lambda real. Okay. An order natural. Okay, so T, so the successor in Tp of eta is the set of, okay, is eta and alpha a possibility. Well, maybe I mix a notation, but it should be clear. So this same fine, but add Cohen's, but and to add Cohen's. Okay. So the problem is the charge forcing a lambda Cohen. It tends to add lambda Cohens because you can't make the decision rightly. Okay, because, well, lambda is different than aleph 0. Yes. So, in fact, you can always think that what various things are very special to aleph 0. This is connected to this, which is another paper, which in fact 2, 3 revised. So if you have comment on section 2, 3 there, no point because it's already revised, but it is in the works for this. On section 1, you know. So what it says the following. I have always believed, and I think that this everybody who think about it know that whereas Cohen has many relatives both in forcing for aleph 0 and in higher things, yes, the lambda Cohen have many other relations which satisfy lambda plus CC, Cohen random many relatives. As Lebesgue measure, this is true both for aleph 0. I think, in fact, it was proved that, well, the only ones are semi-measure, which are essentially like this. And okay. However, believe that this is empty, say not true. What? The belief was that there is no generalization of Lebesgue measure to the lambda, except there is one which satisfies aleph 1 CC, but not one satisfying less than lambda complete and lambda plus CC. So, anyhow, of course, now you can think this, but at least it was very clear to me. And I think everybody else, because Lebesgue measure have no such generalization. So, Lebesgue measure and integration still do not have a reasonable, it isn't even clear by what you replace the real field, yes. However, for the forcing, we need not Lebesgue measure and integration, but null ideal. And this is proof there that for such there are.
You mean there is a random real for an inaccessible?
Yes, when you define having the properties which set theorists expect from measure, which not what maybe people from analysis to say where is the integral, yes?
There's no integral, but there is a random.
Yes, all the properties, bounding, lambda plus CC, etc. It is nice for lambda weakly compact with diamond, etc., for lambda, maybe more, okay, bigger than aleph 0. If you grow smaller, then you have to have more. Now,
Are we going to list the properties you expect from the...
well, as I say, if somebody asks, I will list. Fair enough. I didn't follow what you say. נו, כן, לא. אז עניתי שכן.
משהו קיים שאפשר לצפות.
כן.
תמשול, מה אתה מצפה? מה הייתה הציפייה?
The expectation less Q is less than lambda complete, lambda plus CC, or strategically complete. It doesn't matter. It is a matter of how you say it, presentation. Lambda plus CC. This is 1, 2.
By the way, strategically closed in the sense, there are two notions. It depends whether the bad guy plays at the limit stage or the good guy plays at the limit stage.
Never, every, no, yes, okay, you, yes, you are right. If we have this natural, okay, good guy, we help the good guy. Well, we are nice. What?
You let him play at the limit stage.
Yes. I think this is a very, I think this is more informative explanation. Yes. And lambda plus CC, no, what I say? Lambda bounding. I think that this is what I think that a reasonable set theorist will agree that this is what you expect. But if I take it, of course, I can prove my statement by taking it as a definition. Yes. However, probably this is set theorist, any reasonable set theorist. Well, but for analysts, maybe not true analyst, but maybe somebody like Fremlin, which I think once I have an argument with Yoram Lindenstrauss, he say your guy are coming, your friends, or you're not friends. The guy on set coming, and he mentioned Fremlin, and I thought that he was a measure theorist. Now, though we say contradictory thing, I don't think there was really a contradiction. But, okay, so probably is Fubini or symmetry. Yes. If we add one random and then another random, it is just as if it was inversely the same with Cohen, but essentially this those are the only ones, except I don't know, somewhat Talleyrand built some measures which I haven't learned, so the one who write all the time don't suffice to read, so I don't know whether they satisfy it or not. Anyhow, I think, well, if anybody want to protest this as reasonable, I will be happy to hear what he wants. Yes. Now, large part of 1004 was dedicated to trying to prove that it is similar. For example, by looking at Chichon diagram. Yes. What am I? If you want to correct my pronunciation, you should. Yes. No. I don't claim to pronounce it well.
You pronounce diagram correctly.
What?
You pronounce diagram very well.
Oh, yeah. Yes, I believe so. This reminds me of some Israeli and somebody who come from Russia discuss, and the Russians say how horrible are the ze and the the Russian. He doesn't understand what they are and why people do. And then the Israelis say, "They clear. What problem?" You are right. Yes, so this reminds me what you say on my pronunciation of diagram. Okay, so what do we do here? I will suffice to have all, but I try to use an illusion from a well-known book to explain how you do it and how we applied it. Follows Winnie the Pooh. Yes? Okay, what does he say? He at one point where I say he was stuck with rabbit somewhere, and they try to get out and return. So you tell him, why do you want to go away? You should rather try to come back. I say, if I come back, I will certainly arrive. He say, well, if you go away, you don't succeed. Maybe if you try to come back, you will go somewhere else. And this is what we do. We try to make it more, make the forcing more like Lambda Cohen, and end up somewhere else. Well, specifically, let S lambda set of inaccessible and we try to add eta into to the lambda by initial segment. Yes, there is only trunk. Yes, but with promises that eta restricted to kappa, kappa to S is quite generic. Yes? We want not only the end result to be generic. So instead of trying to look at the end result at lambda and make it different than Cohen, we go the Pooh advice and we try to make it more like Cohen before it. So the price is that we have to change the forcing all along the way. Okay? So we define Q kappa by induction on kappa in S star union lambda. Okay. P belong to Q kappa is eta is the trunk. S is included in S intersection S included in kappa intersection S star is nowhere stationary. So not only it is not a stationary subset of kappa, but no initial segment is stationary. Well, they are normally inaccessible, so anyhow. Okay, 1 minute. Okay. Maybe I should have been wiser and write first here. So this is this was 1, this was 3. Okay. Here we have 4. Okay. So a station where we were. Yes. Okay. And here is lambda. What is lambda bar? Well, I know that this is partial derivative. However, in my writing, partial derivative are very rare, so I allow to steal this. I don't think the partial differential equation will read it and protest. So, okay, delta lambda is a set of at most del predence set of Q del. Remember, we are defining by induction. Yes? We promise the generic branch will pass through them. So order is natural. Yes. What?
What is the index set of the
This?
Yes.
Okay. This is uppercase lambda. Okay, it is a Greek letter and it look like, I don't know, at least I don't know if my Chicon is better than my Greek handwriting, but for me at least it looked like this. Does you recognize it?
No, I mean this set. Which set?
Well, it is part of, okay, let us see. We are defining, in order to say that we go in the direction of super Cohen, we say that previously we have tried to be Cohen. So we define the forcing by induction on the cardinal, yes? So if we arrive to kappa, we already have defined the forcing for smaller cardinal in S star, yes? Okay? And this, so this is a set which look like this. So you ask, but so here, this was already defined by the induction. So it is this.
What is lambda? Is lambda an ordinal? Is it a set? What type of
Lambda is a set of at most, del lambda is a set of at most lambda predence subsets, yes? No, 1 minute. Del lambda is a promise that the generic, we promise the generic branch restricted to lambda, restricted to del, will pass through them, yes? So not only the generic branch should be generic, because this is what it means to be generic branch.
How many promises you have?
At most del. Oh, 1 minute. No. I'm sorry. I'm sorry. I'm sorry. Naturally I read what I intend and not what I write. Sorry. Okay. So we have now, but come on, if you remember Chekhov, if there is a gun boiled on scene in the first act, it should fire in the third act. So we have in the second act, we have a non-stationary, nowhere stationary set. So this should appear somewhere. It appears as the index set of lambda bar. Okay, so for very rarely, but still a non-reflecting stationary set can be still large, yes? Okay, and the order is natural. Now what we do?
I to understand that you also can increase S.
Yes. So P less than Q, Q kappa implies, so the trunk of P is initial segment of the trunk of Q belong to the tree of P. This is those which P think possible, which is starting with a trunk and promise to be quite generic. Yes? And SP included SQ and delta is include a P in del Q del. So I think this is justified to say, I'm justified to say that this is natural, yes. Okay? So now what do we have in the iteration? Okay? The iteration. Okay, so two. Okay.
So does this satisfy the three requirements?
Say again?
Does this single portion satisfy the three requirements that you want?
Oh. If Sx doesn't belong to weakly compact ideal of lambda, it satisfies. Okay. If you want to have smaller cardinal, you have to make, so this definition you can take as kappa says a set of inaccessible, okay, or strong limit. So it has pure definition with no parameters. If, however, you want to have smaller cardinals, there are remedies, and this is written, but Shani Cohen is finishing right with me on this in her MSc thesis, etc. But this will be, then it is more complete. But I look, so for weakly compact, this is, you will get all properties which I promise. Yes, all those. Yes. To get lower, you have to pay something. Yes. Okay, but there is one, and well, is it weakly compact large cardinal? This depends on your. I think most set theory will say it's compatible with L, so it is very small. But okay, we are given index set, say a copy of lambda plus, yes. And Q alpha is above for each alpha in U. For simplicity, all the same. Okay? Now, how will a condition look like? Okay, the iteration. Okay, we define, again, we define Q kappa V, V included in U. You can make it equal, yes, U, by induction on kappa. Yes? Okay. Now P belongs to Q kappa V, if P consists of I think writing in one sequence will be this. Okay, so let us see. Zeta down less than kappa. This is the height of the, it is a parallel of the length of the height of the trunk. But of course I ignore maybe, each Q alpha use parameter, add a subset of some U alpha bigger than kappa, lambda. So this is very important, and I spend large time in the paper on doing it, but we have at least my impression is that I suffer from it lost more than you. Okay, so this is the height of the trunk. 2, trunk P is eta trunk P, oh no, I'm sorry. U bar is U epsilon between zeta up and kappa. U epsilon included in U, and U epsilon, let us say, is mostly U epsilon. Okay? Can be say more, but this is U bar increasing. Union is UP this is the domain. If we have iteration, then a condition will have a support or a domain support. It should tell us, it should speak on some coordinates, and the number of coordinates cannot be too large. So it's vector. We speak on imitation of countable support, so it will be naturally kappa. Okay. Oh, I think I have succeeded to swallow the eraser. Oh, here. Maybe I swallow, but they are not irreplaceable. Three AP, okay, no. AP, a club of kappa, minimum AP is zeta. Yes, so it starts with this. This is the case. Now, what will occur? We want in each coordinate for every alpha, for every alpha in UP, we have a nice name, short memory of a member of Q alpha. Yes, Q alpha was as I described before. Now, if we allow total memory, maybe we will succeed to get from it, not so clear. But as I say, there are many other possibilities of various degrees of.
What do you mean by short memory?
I'm sorry. This is commercial, or this is like promises before the election. I will deliver in a little. So we will have H alpha. Okay. For alpha in U and epsilon less than lambda kappa such that alpha belong to U epsilon 1 minus U epsilon, H alpha epsilon will compute the trunk of P alpha from, now not from all the generic previously, but some small fragment from eta beta restricted to the successor. The successor in AP of epsilon, this is just the first ordinal bigger than epsilon, which is in this club. So it is a club, so this is well defined. For beta, beta belong to U, but which U? Again, this U. Successor AP epsilon. Successor AP epsilon is minimum of AP minus epsilon plus 1. Okay? So this is a reasonable memory considering that we want to have it bounding. So there should be, in particular, if we want to compute P alpha from the previous generic, we know that we expect that there will be somewhat continuous reading of it, yes? So this is a way to explicate this. Make sense? Okay. However, now, okay, so what we have arrived to 4, 5, S included in S star minus zeta down plus 1, nowhere stationary, yes, okay, at least I don't repeat my previous error, so this is this, and delta alpha is a family of at most del maximal anti-chain, predence set of Q del U del, yes. The induction is on kappa for all subset. Oh, I think I have forgotten UP is included in V. Well, why otherwise we have V, yes? This is the only role it can have, yes? Okay, makes sense? Makes sense? We define, what we define is, here, we are defining by induction on kappa for all subsets. Okay? Okay, so here you ask why we want this, because we need this, yes? Those are maximal anti-chain in this. Maximal subset are predence even above. Well, in Q del V. Okay, there is here more, but I will go to it, okay? So now we want, on the one hand, to have, well, it is not a general iteration. We have just those creature forcing, which, however, are much more general than taking something specific. But of course, they are infinitely specific compared to, general nice forcing. And the iteration is fit to bounding because we have decided to deal with this case, which is the one in which the situation is most clear, and in fact is this parallelly for Aleph 0. There is similar situations, though of course there are important things otherwise. There are beginning of it, but not for now. And in order to get the bounding at all is created, because every single one is not per se, it wasn't bounding before we make the correction by the iteration. Now, you can ask if the forcing after the correction has any connection to the original one. Yes, we can correct till, sometimes we correct our way and compromise to satisfy something till, after all compromise, nothing remains of the original. But in fact, if we look at examples, the main property of what we want, say we have a filter for each on each node, and we want to eventually get into member B, on the average being member of the filter. So if we have chosen a member of the filter for every epsilon, our generic will eventually be there, like being bounding some product. Then this is preserved. So I feel it is very reasonable. And that is, and I think the worst crime of a speaker is not saying wrong mathematics or dull mathematics, but overtaking its time. So I have already done it, but not too much. So if you have patience for questions, I will be happy to answer.
So you can iterate to any length?
What? Oh, I have more. Oh, okay. And yeah, okay. My watch was. I see. Hopefully, it was very generous. Okay, what you asked?
So you can iterate to any length and maintain lambda bounding.
1 minute. But you make collapse cardinals. Okay. So if you want to have any lengths and not collapse, question, any length? Here up to lambda plus plus. So if 2 to the lambda is lambda plus, no cardinal collapse. If you like bigger than lambda plus, need more. Okay. Now, C epsilon may be Q epsilon less than epsilon plus complete of cardinality less than the successor of epsilon in S star. Okay? Yes, okay, so you can it fail no chain condition. Yes? There is no chain condition requirement. You may ask C epsilon real essentially D epsilon less than epsilon plus complete filter. Yes? it is less than fitted. So the generic main property for every A in the product of the epsilon for every epsilon large enough, the generic in epsilon will belong to A epsilon. Yes? So you enter this. So this is what I meant, that the correction does not interfere with this property. This seems to me like the property you know, this is why you want, in some sense, to force with it, and it's satisfied. And of course, it is okay.
So I guess as a result, you get the fact that you could have a situation where, let's say, 2 to the lambda is large, but let's say lambda double class, and the bounding number is...
No, the assumption is that the first case where I concentrate on, where it is lambda plus plus, it will be, for example, like there are results that in Chicon diagram all there are no more ZFC theorem on inequality. Yes, well, maybe not taking all subset, but at least all pairs. I haven't written down what it seems like this should do it. If you want to get larger, you have to make restriction that each individual forcing satisfy something like a sigma center. So it is lambda center. So if you fix the trunk, so each creature is like a filter. They are directed. Well, it can still have large power, but you can't have two contradictory demands. So this will give you when you want the thing to be larger. Well, I'm happy to hear that everybody else has understand everything. Well, they didn't have this. So I don't know if this was successful convincing you that this is very interesting. At least it has forced me to advance in writing the paper, so some benefit come out of the lecture. Nachem, עוד משהו? What? Yeah.
What would be the generalization of, say, the Borel conjecture for an inaccessible lambda? So what would be a strong null?
This, by the experience, Borel conjecture. Well, adding lambda undominated, undominated lambda real, well, no sum, but far from this, adding lambda dominated less, okay, and the Borel conjecture require dominating like Lever real. So it seems we are in this far off. But dual Borel conjecture, reasonable. Okay, I have written on it but didn't check it recently, so I can't tell you what exactly, but I remember that when I last looked at it, it seems very reasonable that you can do it. But I can't, but it is not fully written, it is partially. But for the Borel conjecture itself, which there is no problem to formulate, because in fact it doesn't use random, it uses only Cohen. So there is no question of how to formulate it. Yes? But this requires that we know on iterating, adding lambda dominating. I start to deal with it. It requires some compact cardinal and then to define various filter, and I didn't, okay, mathematics is large and time is short and the workers are lazy, so I haven't arrived. But that is not totally stuck, but it is clear that there is considerable amount of work needed for it.